We're going to be solving for all solutions as well as one lap around the unit circle. When we do all solutions, what we want to do is we want to continue to go around the unit circle, and we do so by adding 2 pi repeated times. So we write that as plus 2 pi k, where k is an element of the integers. That just means k is an integer. And integers are all the whole numbers and they're opposite. So it's like I'm adding 2 pi k once and then twice and then 3 times, 4 times, 5 times. Or I'm doing it backwards once, so -1, backwards twice, -2, backwards 3 times, -3. So for solving for all solutions, I kind of go through the same process that I do for one lap around the unit circle. I just add 2 pi k on the end. So remember, when you're solving for one lap around the unit circle, you're restricting your values between 0 and 2 pi, and this is what we're used to doing. So for example, in problem number 1, when I solve for this, I am going to, what I like to do is just replace the trig function with a variable and solve it like I would normally. So that means x equals -1. However, I'm not really solving for x, I'm solving for the sign. I want to find out when the sign of theta is -1. Well, that's down here when I have the point 0, -1, and that's at 3 pi over 2. So if I was solving for one lap around the unit circle, my answer would be 3 pi over 2. But because I'm solving for all solutions, I add plus 2 pi k, where k is an element of the integers. And so that's the only kind of addition that we're going to do, on top of up in the ante in our solving a little bit. So when I do a problem like number 2, again, I'm going to replace that trig function with a variable and then solve. Just do some algebra. And then I'll replace it what I'm actually solving for. So tangent theta is what I'm solving for. I want to figure out when the tangent of theta is 1. And I go through this process just like I was solving for one lap around the unit circle. I need to figure out when the tangent is 1. That happens when the sine and the cosine are the same. So I know that's the pi over 4 family, and that's in the first and the third quadrant. So my answer is pi over 4 in the first quadrant. Because I'm solving for all solutions, I add 2 pi k. And my answer is 5 pi over 4 in the third quadrant, and I add the 2 pi k, where k is an element of the integers. So that would be my solution for that step. So kind of the same process again as we did last time. It's just that we add the 2 pi k on it. I do also want to point out that for tangent and tangent only, we can write this a little bit differently because tangent, remember, uses both sine and cosine, so it repeats itself in half the time. We could write this solution by saying theta equals pi over 4 only plus pi k, where k is an element of the integers. And so that's kind of a more efficient way of writing it, and it happens to work because if I'm looking at my unit circle in the first quadrant, pi over 4, in the third quadrant, pi over 4, they are exactly pi apart. So I could just go pi, I'd get to my second answer right there, and then back into the first, and then back into the third, and I could keep doing it that way. Now, either or is acceptable. Not one is better than the other. Some people like the first method because it's more consistent with everything else we're doing, while other people like the second method because it's more efficient. So you can kind of do whatever you want. Now, there are going to be a handful of little bumps in the road that we have. So for problem number 3, again, I'm going to solve like normal. 1 equals 2x. I'll put in a variable, divide by 2, 1/2 equals x. But again, I'm not solving for x, I'm solving for sine. So I want to know when the sine is 1/2. That's in the pi over 6 family in the first and second quadrant. So far, everything should seem pretty normal. So that's theta is pi over 6, and theta in second quadrant is 5 pi over 6. Again, I add my plus 2 pi k, plus 2 pi k, where k is an element of the integer. Again, pretty normal. Add on to the end. But like I said, sometimes there's going to be some bumps in the road. And as you see me solve problem number 4, one of those bumps happens when I start to mess with the angle. Now this is going to affect what we add in the end because it affects the period of the function as well as what the angle's answer is. So this is going to have an effect in 2 spots. So that 4. First of all, instead of adding 2 pi k, because that 4, again, adjusts the period, how long it takes to repeat itself. I'm going to do 2 pi divided by 4. So on this, I'm going to be adding plus pi over 2k to my 2 answers. Okay, so that's one spot that's going to mess with us. The other spot is when I start to solve this, negative 6x divided by negative 6 divided by negative 6, I get 1/2 equals x, and you might be thinking, well, that's the same answer as the last one. It is, except for I'm not solving for x, I'm solving for the sine of 4 theta this time. And so when does the sine equal 1/2? It equals 1/2 in the pi over 6 family in the first and second quadrant, but it's not theta, it's 4 theta equals pi over 6. And 4 theta equals 5 pi over 6. So now I have to solve those, so I'll divide by 4, divide by 4. I get theta equals pi over 24, and theta equals 5 pi over 24. And then I'll add my plus pi over 2k plus pi over 2k, where k is an element of the integers. So that messing with the angle is going to affect us in those 2 ways. It's going to affect what we add on the end as well as what angle we're actually solving for. So the next problem is very similar to that, where I've got something affecting my angle. And so I have to remember that I would do 2 pi over 2 gives me pi, so at the end I'm going to add plus pi k on this problem. And when I solve, I get negative 5 plus x equals negative 11/2. I will solve by adding 5 on both sides. X is negative 1/2. But I'm not solving for x, I'm solving for the cosine of 2 theta. So take cosine of 2 theta equals negative 1/2. The cosine equals negative 1/2 in the pi over 3 family, and it's negative in the second and the third quadrants. So when I solve or set up my answer, it's not just theta, this is 2 theta. 2 theta equals the second quadrant, pi over 3 is 2 pi over 3, and the third quadrant, pi over 3 is 4 pi over 3. So then when I divide by 2, I'll get theta equals pi over 3, and divide by 2 again, and theta equals 2 pi over 3. So I'm just doing 2/3 divided by 2 and 4/3 divided by 2 and then sticking the pi back in. Then I'll add my plus pi k, where k is an element of the integers. So I'm going to go back to solving for one lap around the unit circle for the next 2, and these are the last 2 that we're going to do that we did for the first day of the notes, and the second ones you should have watched in the video today. But so here I know I'm solving for one lap because it says solve each equation from 0 to 2 pi, and so I'm going to be only coming up with those single answers or double answers. Usually we have 2 for each situation, but I'm not going to be adding the plus 2 pi k on it. But these are stepping up my solving a notch. I'm still going to do the same thing where I plug that into x minus x squared plus 2, because I like to see it with variables to solve, and I recognize that I have a squared here, so I must have to factor to solve. So I bring everything to one side of the equation. So I add the x squared, I minus the 2x, I subtract the 2 from 3, and then I'll factor to solve. So x minus 1, x minus 1, x minus 1 equals 0, and x minus 1 equals 0. So x is 1 and x is 1. I don't really need to write that both times, so really what I'm looking for is when is the cotangent equal to 1? Well, again, the cotangent is equal to 1 in the pi over 4 family, because that's when the cosine and the sine are the same. And it's positive, so it's in the first and the third quadrant. So theta is equal to pi over 4 and 5 pi over 4. No plus 2 pi k because I'm only solving for one lap, so I can end my answer right there. The last equation that we're going to be working through steps it up even another notch. Now I have two trig functions. How do I deal with that? Well, I'm going to call cosine x and secant y. And so I'll plug in those two variables. So this is negative xy plus the square root of 2x minus 2y equals negative 2y. And I'm going to get everything on one side of the equation again, just like we did when we were factoring to solve. So I'll add the 2y to both sides, and you'll see that that cancels out. So I'm left with negative xy plus the square root of 2x equals 0. I recognize that they both have a factor of x in, so I'll pull that out. So negative y plus the square root of 2 equals 0, and then I can solve for both of those factors. X equals 0 and negative y plus the square root of 2 equals 0. So this one is when y is the square root of 2, and the other one is when x is 0. But again, I'm not solving for x and y. I'm figuring out when the cosine equals 0 and when the secant that is, equals the square root of 2. This one's not so bad. Remember, cosine equals 0 at the top and on the bottom, so that's when theta is pi over 2 and 3 pi over 2. The secant one is a little bit newer for us, and so it takes a little more thought on that. Remember, when we're solving for the secant, one of the easiest ways is to write it as its reciprocal function. And this might not look familiar, but when I rationalize the denominator, I get the square root of 2 over 2. So I'm trying to figure out when the cosine is the square root of 2 over 2, and that should look familiar. So that would be in the pi over 4 family, and it's positive in the first and the fourth, so that's pi over 4 and 7 pi over 4. Now, what you worked on, or the video that you watched today, is just continuation on this. So you sort of, if you watched today's already, you started with the hard material and went down to the kind of easier stuff, and hopefully that helps make it more, or helps put some more sense into it. Well, regardless, your homework is 4-3, evens or odds. Hope you're feeling better, and I'll try to send you videos each day. We are going to be doing a review, and your test is virtual, so I'll send you the review through the review answers through Classroom. All right, if you have any questions, just ask. Have a great one.